Do you know that the human eye is far more powerful than you think? Yet it completely fails in the dark? Have you ever wondered why we can see millions of colors in daylight, read tiny letters on a screen, and recognize faces from far away? But the moment the lights go off, everything turns into complete darkness. Today, you're going to learn the fascinating truth behind why our eyes cannot see in the dark. And the answer is deeper, more surprising, and more dramatic than most people realize. Let's start with a moment you've experienced many times. You walk into a dark room. For a second, you can't see anything, not even your own hand in front of your face. But after a few minutes, you start noticing shapes, outlines, shadows. You still can't see perfectly, but something changes. Why does this happen? Why are we blind at first, and then slowly adjust? Here's the truth. Humans were never designed to see in total darkness. Our eyes evolved to depend on light, not just any light, but specific types of light to function. And without this light, our eyes are like cameras without power. Inside your eye, there are two powerful sensors, rods and cones. Cones allow you to see colors, details, and bright images. But cones are almost useless in low light. They shut down when the environment gets too dark. Rods, on the other hand, are extremely sensitive to light. They help you see shapes in dim conditions, like during nighttime. But even rods have a limit. They cannot detect anything when there is ***0 light, ***. That's why in complete darkness, we are literally blind. And here's where things get interesting. Rods need a special molecule called asterisk. Asterisk rhodopsin, asterisk. Asterisk, also known as visual purple. To work, this molecule is extremely sensitive to light. When you're in bright light, rhodopsin breaks down. When you enter darkness, your body starts rebuilding it. This rebuilding takes time, almost asterisk 20 to 30 minutes. Asterisk. That's why your eyes slowly adjust when the lights go off. But in total darkness, no amount of rhodopsin can help you, because the eye still requires at least a tiny bit of light from somewhere to function. But why can some animals see perfectly at night while we struggle? The answer lies in humans developed color vision, depth perception, and detailed sight because we lived in daylight. Predators like cats, wolves, and owls evolved differently. Their eyes have a special reflective layer called the asterisk topotum. Lucidum asterisk, which bounces light inside the eye, doubling the amount of available light. That's why animals like cats can see you in the dark, even when you cannot see them. Humans don't have this layer, which is why our night vision is naturally weak. Let's go even deeper. Your eyes are constantly absorbing photons, tiny particles of light. Even a single photon can activate a rod cell. But in complete darkness, there are ***0 photons. Nothing enters the eye. Nothing strikes the rods. No signal travels to the brain. It's like trying to take a picture with the lens cap on the camera is working, but there's no image to capture. And here is something surprising. Your brain actually creates fake images when it has no light to work with. Those little sparkles or colors you sometimes see in the dark, they're not real. They're your brain inventing signals because it hates silence. The brain always wants input, and when it gets none, it creates its own. But there's more. Darkness triggers a completely different system in your body. Melatonin production. When your eyes detect low light, your brain starts preparing for sleep. This hormone makes you relaxed, slow, even emotional sometimes. That's why people often think deeply in the dark, cry in the dark, or feel different at night. Your vision and emotions are more connected than you think. Have you ever noticed that you see better in the dark after you stop looking at your phone? That's because screens overload your cones and destroy rhodopsin. Your rods become temporarily useless. When you put your phone away, your eyes need time to rebuild rhodopsin again. That's why staring at bright screens at night makes it harder to see in the darkness. Your eyes also have a focusing problem in low light. In bright conditions, your pupils become small, allowing sharp focus. In the dark, Your pupils open wide to catch as much light as possible, but this makes your vision blurry, because wide pupils reduce depth of field, the same way a camera lens becomes blurry when opened too wide. Now think about something even bigger. Humans see only a tiny portion of the light spectrum. There are many types of light we cannot see at all. Infrared, ultraviolet, X-rays, gamma rays. Some animals, like snakes and bees, can see light frequencies we cannot even imagine. To them, the world looks completely different. To us, the world becomes invisible without light. Our eyes were built for the daytime world, not the darkness. But even though we cannot see in the dark, our body compensates by strengthening other senses. Your ears become more sensitive. Your skin becomes more alert. Your brain becomes more aware of movement. You might not see in the dark, but your body becomes sharper in other ways. The truth is, your eyes are not weak. They are incredibly advanced, but they have one limit. They need light. Without it, they cannot guide you. They cannot protect you. They cannot show you the world. Light is the language your eyes understand. Darkness is silence. And now you know.